So as promised, pesticides, we know you guys have had lots of questions. There are aspects of pesticides that we'll continue to address along the way. It's, integrated in all sorts of aspects of museum work, including, storage and why we make certain material decisions for, for what, how we're storing objects in stores or in galleries. Okay, so just to start, a quick background. Pesticides and residues are found in museum collections. This is a fact, we all know this. Um, so historically, museums have used pesticides to prevent pest infestation and damage. Pesticides have been used by museum staff since the late 18th century and were more heavily relied on before the introduction of environmentally controlled spaces and integrated pest management, which you may have heard referred to as IPM. Okay. So we're back at this slide I used this slide a couple of weeks ago when we were talking about materials. When I was talking about organic-based materials that you find in collections, the animal protein-based and plant, the cellulose-based materials. These materials are, food for many insects and rodents that you can find in collections and storage. So these are the materials that we're focused on. And just a refresher, the types of materials we're seeing that fall into these categories: hair, the gut skin, quill work, leather and hide, and then the plant-based, the plant and wood cellulose-based examples are birch bark, sweetgrass, bulrush, many fibers that you're going to find in textiles, basketry. So these are some of the main things we're thinking about when we're thinking about what has been treated and also what we want to protect for the future. And this is just a slide showing insects on a feather eating the carrot, going after the keratin, and pesticides, including herbicides and fungicides, were used by collectors and museums in order to prevent or destroy pests and to preserve collections. That's an important point to remember. As we've talked about in the past, there aren't a lot of records. A lot of times, when a piece comes into a museum, or even if a piece has been on a shelf in a collection for a long time. And this practice of adding pesticides is not just a museum practice. People who collected materials in their home personal collections also used some of these methods, despite the health hazards. So just because it came from someone's home doesn't mean that it's absolutely safe. And it also doesn't mean there are over-the-counter things that we use that are also hazardous to your health. So, and I'll get into that a little bit more further down. So pesticides, what are pesticides? They're poisons or toxins that include herbicides, which kill plants, fungicides, which kill molds, and various other substances. They've been used to prevent, destroy, repel, or mitigate pests, including insects and rodents. And pesticides are divided into organic and inorganic according to their main chemical component. And I know we did a really brief overview of those two terms a little while back, but this is just a review. Inorganic typically refers to compounds that include heavy metals such as arsenic and mercury. Arsenic was commonly used as arsenic trioxide or arsenic gas or acid, and mercury was used as mercuric chloride. Inorganic pesticides were often used in powder, paste, or dip form, and the residues stay on the item and continue to be effective for a long time. And they're the ones that for working with a collection, they're the ones that we are able to detect more readily, and we can, or we have established methods for detecting these, and we know they're not going away. Mitigating them is quite difficult because they're heavy metals. The organic pesticides are a little more tricky. They're carbon-based compounds. A common example is naphthalene and paradichlorobenzene. They're both commonly known as mothballs. They're they're both applied either in a cake or crystal form and sublimate, acting as a fumigant. The fumes work best in tightly closed spaces, so you get these in closets. I'm sure you're all at least probably familiar with the smell of mothballs. The residue is expected to evaporate over time, so quantifying how much is left on an item can be difficult. And it's not it's not as understood, trying to quantify uh, the amount and how toxic they are is a trickier endeavor than the organic pesticides that we do know about, and there's a lot of research that's been done. And then it's just not, overall though, I would say my experience working in collections, people are wary of these, but they're not as deadly as as ingesting arsenic or mercury are. So there's a scale. And application methods, there are a lot of them. Let's see. Dipping, the pesticide is applied through immersing the material into a liquid solution, such as gasoline. Fumigation allows the pesticide to penetrate areas that would not be affected by other applications. Let's see, I don't need to go through. You'll have all this text that you can refer back to. Misting, dusting, or aerosol bombing, a pesticide chemical is applied to an area as a mist or aerosol and is dusted over the area. This is an important thing to keep in mind when people were doing these, using these methods in the past. They weren't necessarily always isolating, picking up an item and taking it to a room that is really well, that has a fume hood or has good ventilation. People are going into storage with sprays or, on their back, like you would see like someone doing pesticides in the outside in a garden. So that means those materials could be on shelves, they could be in storage boxes, they could be in all places that you're not typically always thinking of. So as a rule, I really do try to encourage people to wear gloves. You kind of, when you're dealing with these types of materials, the organic materials, plants and animal based that we talked about, I generally try to, as a rule of thumb, be very cautious. And if you can't wear gloves, it's not the end of the world. You really just want to make sure you wash your hands and wash them well. I've worked with collections that have known pesticide application, and we've had tribal members come through and request to not wear gloves, and that is their prerogative. We can't enforce it. We can just recommend it, explain what we know and the concerns. And some people really want to feel the weight of something or the texture of something, or it's meaningful in a way that to them it's important to have feel that tactile experience. And so it's allowed, but we generally, rush them off to a bathroom immediately afterwards so they can really wash their hands and remove any residues that they may have picked up so they don't accidentally bring them to their face or ingest them somehow. The last application is residual sprays. And then, so a little more about the application methods. They vary quite a bit from pesticides, herbicides, and fungicides. Sometimes they're applied by brush. Sometimes you can get like collections. They're not always evenly applied. Understanding the different applications can be important for evaluating an item. Again, these things are not always known. So in an ideal world, we have a log, a history of how things were applied, where they were applied, how often they were applied. In the absence of that, you assume there is some residue there. And then one pesticide could have been applied many times over the course of decades. And I've seen that in museum records where they, you know, they have a routine every 5 years. They go in and spray with the it's called like moth away or some dated over the counter product. So there were like they were. This builds up over time. So it's not just a one and done necessarily thing. And then it's often difficult, as I've already said, to obtain information about the past history of a particular object. So again, just be cautious. So I'm going to go over a couple of the main, like everything that we've been going over in this class, most of these topics could warrant their own like full many-hour class or workshop. So I'm going to go over a few of the main types of pesticides that we've been talking about, and a lot of what I'm saying about them can apply to others. But I'm going to give you an inorganic and a organic example to give you just kind of an overview. So arsenic, we've talked about arsenic a bit. It is toxic. It is a heavy metal and it's very poisonous. They're used in rat poison and in some insecticides, and it's a known pesticide that has been used in collections. For the organic example, I'm going to go a bit more into detail on naphthalene. This is an active ingredient in some mothballs. So not all mothballs are made with the same chemicals. This is a very common one. I think this one has a very distinct smell that is the mothball smell that I'm sure most people have encountered in closets. It's a lingering smell. And this can be really poisonous if it's swallowed, or even if you breathe in a lot of fumes over time. So even if there's a faint odor, if you're using mothballs with naphthalene, over time, it can be harmful to you. Again, not as toxic as arsenic, but also naphthalene is a known carcinogen. Okay. The other type of mothballs are the paradichlorobenzene based ones. I don't know if these ones also have a smell. Overall, the active ingredient is less toxic than the naphthalene. So if you are making a decision, and people still use mothballs, they use them in their home, they use them in collections. I worked in a large museum where an entire hallway smelled like this constantly, and it was frustrating and unfortunate that it's still being used so prevalently. But I learned that, like, to avoid that hallway, because if you don't have to, take in these smells every day, then you're going to be better off. Okay. So I want to bring up material safety data sheets, MSDS, frequently they're referred to as that. You can, this is the best place for you to find toxicity information, and they're widely available. They're provided by manufacturers of toxic and hazardous materials. So if you can just Google arsenic and MSDS sheets will come up. You can Google naphthalene and MSDS, and you'll get a list of lots of different examples. The formats are not all the same. So these are 3 different ones that I pulled up for, I think this is for arsenic. And you can see the different ways that the hazards are shared. this diamond, I think, is very common. I think worldwide, they're switching over to these kind of symbols. Internationally, I think this is the colored diamond is, you see this everywhere, and it indicates, you know, the blue indicates in it's like bodily harm. The red, I think, is for fire. Bianca, do you remember what yellow is? I meant to look this up.
Yellow stands for instability, so it's the reactivity of the material. Like some of them
Okay.
are highly reactive.
Oh, like combustible.
Yeah, all kinds of
Okay.
things. So, and then red's fire, blue's health, and then the white is for any specific hazards to that material.
Okay. But there's a key, and you can, and usually on the MSDS sheet, it'll also just give you, you know, 3 here. Short exposure could cause serious temporary or residual injury, even though prompt medical attention was given. So this is serious for arsenic. Down here, you can see there's the skull and crossbones, and that it's bad for, there's, I think this graph is talking about how bad it is for the environment. And those come in handy for, like, if you're in a chemistry lab and you are combining chemicals, you want to know some of these things. For our purposes, we're really thinking about the blue there, and then the ingestion and skull and crossbones for your personal health. And just because you aren't necessarily working with the raw elemental chemicals in your collections, they exist in the form of residues. So it is helpful to have, it might be helpful to have a binder like this or a digital file where you can reference and you're not always just looking it up on the fly. So a little more detail of the arsenic trioxide, uh, danger hazard statements. So this is the kind of information it will list off. Fatal if swallowed, causes severe skin burns and eye damage, may cause cancer, toxic to aquatic life. And then there's a whole list of precautionary and like what items, and then what to do if you get it on yourself. So like if you get it on your skin, you want to remove it immediately with soap and water. So these are incredibly helpful. And if you are putting together a book, I would just spend some time doing searches and finding the format that makes sense to you. Like some of them, they're going to have tons of information about that compound or that element. And what we're really focused on is the hazards. Okay. So the toxicity of naphthalene and the PBD. They can result in skin and respiratory problems or allergies. Again, these are products that you can buy at the drugstore, and they can still cause you health hazards. So this is the case with lots of things that we can buy over the counter: paints, paint thinners, all sorts of materials. So you just want to be, it doesn't mean you can't use them. It means you want to be really mindful and careful how you use them if you need to use them. Um, Hopefully no one's swallowing, but these swallowing mothballs. But this is good to know. Like, do you have, are you in a collection where you have a study collection and children are going to be handling these things, and children put their hands in their mouths, you know, like it's good to kind of think about, normally if you're handling a collection, you have gloves on, but there are other ways things get used. If a tribal community is loaned an item or an item is repatriated, which I'll go over a little bit later, we also want to be mindful of how things are being used or worn, and what types of hazards, and the range of. The other thing about the MSDS sheets, they can give you um, it's like a scale. So things, you know, are obviously, like, a lot of these are going to be worse for a young person, a smaller person to handle than a larger, older person. Okay, so detection methods. So this is, I think, a good There isn't a silver bullet for dealing with pesticides. It is an unfortunate fact of dealing with the decisions made in the past. I think they were, best intentions. People really wanted to make sure that these things were preserved for the future, and they weren't making, maybe they didn't have all the information they needed. Maybe it just that wasn't part of the thought process, but they had these tools at their hands, and people use them readily. And so now we're just stuck dealing with them. So if you're looking for physical evidence, um, if you're lucky, there's a log. On the left, this is from a museum I worked at in the past. It is called Poison Book. And this is a log of all of it's probably not even completely, I don't know how extensive it is. What is there is quite remarkable. It's like so-and-so, Bianca, on this day, moth, with a catalog number, excuse me, and then the product they used. So the best thing we can do when we find records like that is to share that information. So all of this information, we're actively on this project that I was working on at the Field Museum in Chicago. We have volunteers who are actively pairing this information up from the log into the database. So then anyone who pulls up that record can see, oh, there is this history of this particular product, and then information about that product. You can also label things. Here's an example of a label. There are debates about best practices for labeling, and I'll go over that in a little bit. And then you can find residues. So on the bottom right, you can see all that white kind of like powdery residue in there. I think this is a bird specimen. That sometimes you can see it on the surface, like as a light white dust. Sometimes it's really in there if you're working with taxidermy, and this is extreme. The flipping up of the feathers, you might not necessarily do that on an object. But this is just an example to show you that there are examples of physical evidence. It's not always there, and definitely not with the organic materials. Those are more smells that you're gonna have. And then another thing, if you're working with a new collection, there might be evidence of past practices in the form of labels or equipment or supplies that you find on an old shelf that just say, like, poison or the name of some product. So just kind of being aware of the collection that you're working with. And then I'm just going to go over a few of the detection methods that are currently used. One is microchemical spot tests, and these are, I would recommend that, in order to do these, you're working with chemicals. So you definitely want to be working with someone who is trained to work with chemicals, and you want to have ventilation. This particular test for arsenic produces a mercury product. So it like in those little tubes that you see on the right, when you detect arsenic, there's a little byproduct that is mercury. And I think there might be mercury in the as part of the reaction. So then you're creating more hazardous waste that has to be dealt with. So there's a whole book on different types of like small scale tests you can do like this. I'm not going to go into details on these because I don't necessarily at this juncture recommend that you go out and do this. I just want you to know that these are the methods that are available, and if you're working with a trained professional, they can be done. So this is one of the benefits of this method. It's not that expensive and overall in the grand scheme of things, but you do would want to have a fume hood or some way to keep you safe, and you're dealing with chemicals. But it's non-destructive. So you roll swabs, you're taking a sample, and you can and it's nice because you can get samples from all around an item and pick up. So it's not just one single spot that you're checking, you're collecting, like accumulating around. And then in the middle, there's a picture of a bag with 2 swabs in it. And this is, again, from a project I was working on recently, where we deinstalled 1,500 items. We suspected there was, based on past experience or research, about 20% of the like collection and storage had arsenic residues. So we were pretty sure that all these things that had been on display for 70 years probably did too. And the way, so everything that came off, we swabbed and we put in these plastic bags and labeled, but we didn't actually have time or the money to run the tests. So we have a giant box of swabs that is waiting for the moment when we can do that, but it doesn't mean you can't. Like, we've collected a lot of data that can be useful in the future. So even if you don't have like the means to do these tests, you could still be collecting samples. Some other methods, X-ray fluorescence, or this is a portable X-ray for PXRF and X-radiography. These methods are very common, and Jay's going to go over, I think he uses PXRF, right, Bianca? So I won't go into too much detail. These are both non-destructive. We're not taking samples. The portable XRF is great because it's portable. You can take it in the field. You can take it to different locations. It is both these methods require equipment that can be expensive. And for I would love to sit in on Jay's talk. My experience with doing XRF is that calibration can be difficult. So, and also interpreting your data can be difficult. So it looks like you're just pointing and shooting and you're getting like the information like this, but the way you get a spectrum of these wavelengths that you have to interpret, and some of them overlap, and some of the heavy metals that you're looking at overlap, and it becomes tricky to determine, is that lead paint or is that an arsenic peak because there is a pesticide. So and this I have like some experience with, but I think Jay's going to give you much more information on this, so I'm not going to go into it. And then on the right is an example of a taxidermy bird. Those big chunks of white kind of at the tail and the head and at the front of the chest, those are large pockets of a heavy metal, probably arsenic. So when you're looking at an X-ray, you're gonna still, the heavy metals are gonna be those patches of white.